Hello and welcome to today's math lesson. We are doing chapter 7, lesson 3. So we've been talking about polygons and what makes a polygon. And yesterday we specifically talked about parallelograms. And the definition for a parallelogram is two pair of opposite sides parallel. And then there were some properties that came along with it. So the definition is two pair of opposite sides parallel. And then some things we found out is that both pair of opposite sides are congruent, and both pair of opposite angles are congruent. And we found out that the diagonals bisect each other. And we also found out that consecutive angles are supplementary. Okay, so we went over 5 things. Opposite sides parallel, both pair of opposite sides congruent, both pair of opposite angles congruent, diagonals bisect, and consecutive angles are supplementary. So today what we're going to be talking about, so if I give you this information, you don't know if this is a parallelogram. Can we conclude if this is or is not a parallelogram? Do they give us enough information? So basically, what we're going to be doing is the converse of everything. Okay, so if both pair of opposite sides are congruent, then it is a parallelogram. Okay, so if a quadrilateral has two pair of parallel opposite sides in here. Okay, so what are all of the things? Notice yesterday we went through 5 things and I just listed them on the last page. There's one new one. Okay, so there's one new one coming up. All right, so the first one is, how do we know if we have a parallelogram? So this is the converse. So what we started with yesterday, we have a parallelogram, so both pair of opposite sides are parallel. Well, now the converse is going to be, if we have both pair of opposite sides parallel, then this is a parallelogram. Okay, so if we have both pair of opposite sides congruent, then we have a parallelogram. If we have both pair of opposite angles congruent, then we have a parallelogram. So we're doing the converse of everything we did yesterday. Now, you can barely see here, but we've got some red lettering coming up. So this is the one that is new. This is the new one that you have not done before. So if you have one pair of sides that is both congruent and parallel, then we're going to have a parallelogram. Okay, one pair of sides. So if I take this and make this segment congruent to this, and I tell you that they are also parallel, when I connect these opposite sides over here, this side over here, and this side here, this will always be a parallelogram. So number 5, whoops, that went way up. All right, so if we have diagonals that bisect each other, then we must have a parallelogram. And then the last one is if we have angles that are supplementary to one another. So if we have 2 angles in here, so they are saying that this angle is 180 minus x, and this is x, and x and 180. So we have to have, it is supplementary to both of its consecutives. So if we just say simply that this is 100 and this is 80, that is not enough. You need to have it both. So whether you put the 80 here, now there's enough, or if we didn't tell you this and you put the 100 here, now this is enough. But just knowing one pair, the only thing that this proves right here by having this is that this is parallel to this. That's the only thing that's proven so far. Okay, so you need to have it to both. All right, let's try a few examples here. Now, do we know if this is parallelogram or not? Well, the last one we just talked about, 73 and 107, and 73 and 107. So whether we go this way, they're supplementary, or this way, they are supplementary. So it goes back to this last one that we were just talking about here, and that if one angle is supplementary to both of its consecutive angles, then it is a parallelogram. So this one is yes. Supplementary to both adjacent angles. All right, how about the next one? Is this enough information? If we have one pair of opposite sides congruent, is this a parallelogram? And this is no. We need two pair. We need both pair congruent. So this is not enough information. All right, what values of x and y make A, B, C, D a parallelogram? Well, if this is going to be a parallelogram, then we know that these two have to be congruent. So 3x minus 32 must be equal to 2x. All right, so x is equal to 32. So x would have to be 32. All right, and we also know that these two angles would have to be congruent. So 4y is going to have to be equal to y plus 87. So 3y equals 87. So when we divide by 3 here, 87 divided by 3, we get y is 29. Okay, so the values for x and the value for y, that would make this be a parallelogram. All right, is this a parallelogram? So does it fit one of those 6 reasons? Well, what do we have? One pair of opposite angles are congruent. Do we know for sure that A is congruent to C? Well, let's see. In a triangle, we have this congruent to this and this congruent to this. So by the third angle theorem, does this angle have to be congruent to that angle? So now we have a double and a dot, double and a dot, and a double and a dot. Doesn't this make A congruent to C? So this would be yes. Why? Because both pair opposite angles congruent. Okay, so we had to use the third angle theorem to get these angles congruent in the triangles. And then these together make A and C congruent. So yes, this is. All right, how about here? Is ABCD a parallelogram? So what do we have? We have this side is congruent to this side. All right, then they put a transversal in here. So if this angle is congruent to this angle, isn't this parallel to this? So do we have one pair of sides congruent and parallel? So yes, this is a parallelogram. Why? Because we have one pair of sides that are both congruent and parallel. All right, what do we have going on here? So we have a diagonal and we have All right, 19 and 19 and 36 and 36. So yes, this is a parallelogram. Why? Both pair opposite sides are congruent. All right, is WXZY a parallelogram? All right, we got two pair of congruent sides, but are they the opposite sides? No. Opposite sides, not congruent. All right, this actually is a kite. All right, and we are done with the lesson. The only example that probably was not in there that you need to make sure that you know is if this diagonal bisects this diagonal. Then when we connect these would be this, not these. This would be a parallelogram. Well, not by my drawing, but if they, because the blue one's way off. All right, so if the diagonals bisect each other, then yes, it is going to be a parallelogram. All right, don't look at my bad drawing there, but the concept is true. All right, good luck on your homework for lesson 7-3.